So we're going to have a look at this question that is looking at trig graphs. It's probably worth us doing a quick review of some of the features of trig graphs. We've got our scale here, we've got degrees. So one tool that you can use in your study, obviously not in the exam, is to use our good friend Desmos. So what you can do here is we can just take a look at sine x and look at that as it is. You can see the key feature is it starts at 0, 0. At 90 it reaches 1, then it gets back to 0 at 180 degrees and 360. Just when you're using Desmos, obviously an important thing like using the calculators, we need to make sure we're in degrees. So that's the sine graph, and you need to know what that basic function looks like. Obviously cos x is there as well. You can see it's a slight translation of by 90 degrees of sine, so it starts at 0 degrees it's 1, at 90 degrees it's 0, 180 it's -1, 270 it is 0, and then 360 it goes back to 1. But the question we were looking at was referring to tan. So if we take a look at tan, it's obviously a different being for tan. So you can see it starts at 0, then it goes all the way up to a limit at 90. So we have an asymptote, which means a line that the function never touches. So there's no value for 90. But you can see as it gets closer to 90, it goes into infinity, a positive infinity, and then beyond 90, it starts from negative infinity, all the way up to 180, back to 0, and then there's a point of inflection, and then it goes back up there with another asymptote at 270, all the way to 360. So going back to our diagram, we need to make sure those things are really clear. So first thing is we can put in our asymptote with a dotted line at 90. We can put in another one at 270. And then we put in our function. So again, making sure we start at 0, 0, going all the way up to there, to our extreme limit, and then our point of inflection at 180, and then trying to get that curve nice and smooth, and then doing the same there as well. So as far as the marking is concerned, the key points is to make sure you look at your limits, your range, so that we've got between 0 and 360, that we've clearly put where the asymptotes are, and we've made sure that our point here starts at 0, ends at 0. There's a point of inflection at 0, and we've made that function really clear. So the second part, when it talks about solving the equation, again we can go back to our Desmos and have a look at what effect changing that to 5 tan would be. And you can see that that's a transformation where it stretches it out further. Desmos has the added bonus we can also put in that y is equal to 1. And then you can see there that gives us what the values would be. So you can see there at when 5 tan x is equal to 1, we've got our answers there. So it would change it. So how we answer that on our question is obviously we can go tan x is equal to 1, 5. So we can solve it in our normal way. We can divide it by 5. They cancel out. And then we can divide this one by 5. So that would give us tan x is equal to 0.2. That's when we involve our calculator. I'll make this. Alright. So then we can solve that. We need to remember that to find x, it's going to be inverse tan of 0.2. So on our calculator, if we do that, we can go inverse tan inverse tan 0.2, and we end up with 11.31. And obviously between there and 360 there's two answers, so we don't include that one because it's beyond 360, and obviously anything less than that would be less than 0. So the difference between those is 180. So I need to remember that it would also be 191.31. If you do need any more practice of that, and the key thing is obviously make sure you can answer the questions for sine and cos as well. So make sure you take a look at those.